I had a different video planned for today, but I just had an exam yesterday and there were some really good questions on that exam, and I really want to make a video about some of these questions, and this was one of my favourite questions on the exam. It's really interesting and I think it's a really useful skill to have. Hopefully we can just get some practice and do this question together. So I'm not going to put the exact question that was on the exam, it just has different values in it. I wish I had something to like put this on. Okay. As soon as I get this little stool to put my piece of paper on, what do? I put my feet on it. It's not for feet. It's for my notes. Maybe I put it there then. Oh, that's better. So I find this sort of function interesting. Well, I find these limits interesting. It's actually a circle. And I always find it fascinating how you can have limits of integration that end up being a circle, where that lower limit is one semicircle and the other limit is the other semicircle. Okay, so this is the question. It is... So, it's being integrated twice. Double integrals are integrated by iteration, so however many times you're integrating, 1, 2, 3, 4, then there'll be 4 steps, and they're iterated from the inside outwards. This differential y is belonging to the limits on this inner integral. So for this question in particular, they've chosen the limits. The upper limit is the square root of 9 minus x squared. If you think of what this looks like, if you rearrange this, it's going to be a semicircle. It's going to be the positive y part of the circle. And this question has the lower limit as the negative circle on the y-axis. So it's just going to look like the negative version of that. Because whatever you will get out of this will give you the negative version of that. This outer integration limit belongs to this differential here. So we have 2 straight lines and 2 semicircles. So to visualize these limits here, it's good to rearrange them into something that's probably a bit more familiar. So remember that because this is with respect to y, the output is y. So this is how we're going to write it to begin with. So that's the upper limit, and we want to rearrange it into the equation of a circle. First we square both sides, and that will give us y squared is equal to 9 minus x squared, and then we can bring the x squared onto the other side so that we get y squared plus x squared is equal to 9. And to fit it into the equation of a circle, that we know if 9 is equal to r squared, then r is equal to 3. So what this is saying is that it's all the positive values of this circle. Basically, it's not offset from the origin because there's nothing messing with the y squared or the x squared. It's showing you that it hasn't moved from the origin. And the 3 squared is showing you how far the points on the circle are from the origin. Okay, so let's go ahead and draw our circle, semicircle. Remember, it's only the positive values, so that's going to be above the x-axis. it's going to look something like that. You can see that that's the upper limit because it's only taking on positive values. Like that. When we're going to be integrating with respect to x, after that, it's going to be two straight lines. And they're just on the border of our circle. So these are our limits, and they're already in a form that we can draw. X is equal to 3 and x is equal to -3.